Hi, in this video, I'll be doing a mathematics entrance exam from Cambridge. I'll just share the exam real quick so that you can see what it is. So it's a 2019 exam. It's a mathematics exam to be admitted into Cambridge. Calculators and dictionaries not permitted, and no formula sheet, which is quite daunting for me because I really like my formula sheet and my calculator. Yeah, it should be fine. I should be able to do all 20 questions if I still remember all the stuff that I learned in high school. Okay, I'll stop sharing and I'll join my iPad real quickly. I got the idea to do this video from Tom Rock's maths when he did a similar type of exam. Okay, and I'll share my screen. Okay, so here's the exam. Here's the front cover again. So 20 questions, no calculators or dictionaries, and no cheat sheet. And I have 75 minutes to do it. Okay, hopefully this all goes well. Okay, first question. F of x quadratic function. So that means f of x takes the form ax squared plus bx plus c, where a, b, and c are real numbers. We're given that it passes through the point 1, -1, and -1, 3. So that means f of 1 is equal to a plus b plus c, which is -1. And f of -1 is a minus b plus c, which is 3. Furthermore, we know that -1, 3 is a turning point. This implies we have to differentiate f of x, which is 2ax plus b. But then that means that f prime of -1, which is -2a plus b, is 0. This then gives us b is equal to 2a. Now we substitute. So let's make this equation 1, equation 2. Substitute b equals 2a into 1 and 2, so that we get 3a plus c is -1, and minus a plus c is 3. We can subtract the two equations to get 4a is -4, which then gives a is -1, b is -2, and c is 2. Therefore, f of x is -x squared minus 2x plus 2. That should be right. And the answer is A. Okay, that wasn't so bad. Question 2. Find a complete set of values for which the expression is always positive. Okay, so if it's always positive, that means it's either a perfect square like this, or if it's just floating somewhere above the x-axis like that. And that should mean that the quadratic here has greater than or equal to 0 discriminant. Or I can just like this, or less than, should be less than or equal to 0. less than or equal to 0. So so notice that this, you can rewrite this as that. Then we invoke the quadratic formula. So minus k plus 2 plus or minus square root k plus 2 squared minus 4 times 1 minus 2k over 2. I guess we expand what's inside here. 4k plus 4 minus 4 plus 4k over 2. And this gives k squared plus, made a mistake here. This should be plus 8k, so that this is 12k. Okay, so the discriminant is inside here. So that means k squared plus 12k should be, which is k factored out like that. So we have this inequality. Then I guess you would get this. And this, k plus 12. So the quadratic will look something like that, where this is minus 12 and this is 0. And so this is the region that we want. So the answer is A. Find the coefficient of x in the expression. Oh, wow. Let's see. Find the coefficient of x. I guess we will. Yep. So the binomial theorem. I think this is right. X to the k, y to the n minus k. Then what is the one? Coefficient of x. And then, so that means 1 plus x to the n is just that. Yep. Okay. So since we want x, k is equal to 1, because if k is equal to 1, then we have x. Okay, so we ignore everything else except when k is equal to 1. And then I guess you just, then we calculate n1, which is just n. I mean, I can write it out a bit better, which is that, which is n for n this interval. But I guess this is really easy. This is just the sum as I goes from 0 to 80 of I, which is just 80, 81 over 2, which is 40 times 81, which is 3,240. And the answer is E. Okay, that's question 3. Hope that's right. The sequence xn is given by, so the first term is 10, and then successive terms is given by this recursive formula here. Okay, let's write it out and see what happens. So I'm guessing x2, which is x1 plus 1, which is the square root of x1, which is the square root of 10. Looking at the answers, I'm guessing I have to write it as 10 to the half. Okay, then x3, which is x of 2 plus 1, is the square root of x2. The square root of that. Okay, yep, I can see the pattern now. I think you can conclude that x to the n plus 1 is equal to 10 raised to the 1 to the n, or 10 to the 2 to the negative n. And then x to the 100, which is x to the 99 plus 1, is 10 to the minus 99. And the answer should be C. That looks right. Good. Question 5. S is a geometric sequence. The sum of the first 6 terms of S is equal to 9 times the sum of the first 3 terms of S. So geometric sequence. So the formula has A as it's like its first term, and R is like the ratio. And I believe the formula is something like this. For the sum of n terms. Maybe it looks like, maybe it's this instead. Let's go with this and see what happens. Okay, so the first 6 terms, that just means A of 1 minus R to the 6, because here n is equal to 6. This is equal to 9 times the sum of the first 3 terms. Okay, so then we can multiply by 1 minus R on both sides, so that these cancel, and I guess divide by A as well, so that these cancel, so that we get 1 minus R to the 6 is equal to 9 times 1 minus R to the 3. I'll rewrite this as 9 minus 9 R to the 3, so that if I move everything to one side, I'll get R to the 6 minus 9R cubed plus 8 is equal to 0. This is one of the classic substitution questions to get your polynomial to look like a quadratic. So if you let x equal R cubed, then I'll label this as star, then star becomes x squared minus 9x plus 8 is equal to 0, which factorizes into what, x minus 1, x minus 8, which then gives x equals 1 or 8. But then that means r cubed is equal to 1 or r cubed is equal to 8. This means r is equal to 1, r is equal to 2, but we know that r is not equal to 2 because if r is not equal to 1 because if r was equal to 1, then if you substitute back into the original equation, you get undefined. Therefore, r is equal to 2. Then what? The seventh term is 360. So to find the nth term rather than the sum of the first n terms is really easy. It's just an is equal to the first term times the ratio to the n. But now we know r is equal to 2. So that means and n is equal to 7 because we want the seventh term. So a7, which we know is 360, is a times 2 to the, oh, this should be a minus 1. This here should be a minus 1, so that this gives us 6. But then that means 360 is equal to 64a, which means a, which we know is the first term, is 360 on 64, and it simplifies down to if I divide by 4, if I divide by 2, aha, so the answer should be E. Okay, that was a tough one. So, circles, all right. The circles with equations that have exactly one point in common. Okay, so since they have exactly one point in common, then let me zoom in a bit. That means the two circles meet at their boundaries. That is the only way for two circles to have only one point in common. Let's see. So this circle, the first one, has center -4, -1, radius 8. So remember, it's not 64, it's 8 squared. And this one has center 8, 4. Okay. Find the difference between two possible values of r. So when I say they meet at their boundaries, there are two scenarios where they meet at the boundaries. So the first case is just them touching like this. And case 2 is when one of them is contained inside the other one. So something like this. Hope that makes sense. So let's say this was our first circle, and this is our second circle, and this was our first circle, and this is our second circle. This is 8. And whatever this is R. So this is 8. And then whatever, I'll do this instead with red line. Hopefully that is still okay for people to see. Let's make that R. Now what? I guess you can find the distance between the two centers. So distance is the square root of -4 minus 8 squared plus -1 minus 4 squared. So that's 144 plus 25, 169, 13. So that means that the distance, so the distance from here to here is 13. So I guess R is equal to 5. That's one of the possible values. What if I have what if I have the second circle inside the first one? So if this is 2 and this is 1. Let's say this is the center. Let's see. Well, I should probably be realistic. So 8, 4 is definitely somewhere above 4, 1, -4, -1. So it's got to be here. Here's, let's say here's -4, -1. Let's say 8, 4 is, I don't know, somewhere up here. Ah, I see. We know that the distance between here to here is 13, as specified by this distance here. So this is the distance between the two centers. But then we also know that the little circle, which is circle 1, has a radius of 8. So here to here, let's say it's 8. So then the total radius here is 21. Great. So then the two possible values of R are 21 and 5, and then it wants the difference. So then the answer is C. Hopefully that's right. I'm not very good at circles. Question 7. A curve has equations y equals that, the gradient of a shore, I'll just expand this and see what happens first. What's this? 4q squared x squared plus 6q minus 2qx cubed minus 3x squared. I can rearrange that to make it look a bit better, I think. 3x squared oh, this shouldn't have a, this is a linear. Okay. The gradient of the curve at x equals -1. Okay, so dy dx is minus 6q x squared minus 6x plus 4q squared. And then when you evaluate this at -1, you get minus 6q plus 6 plus 4q squared. I'll just rewrite that. Okay, and notice that this is indeed a function of q. So now we want to minimize it. So we let, I don't know, z equal 4q squared minus 6q plus 6. So that dz on dq is 8q minus 6. Yeah, what? I'm guessing we make this equal to 0 so that q is equal to 6 on 8, which is 3/4. And I'll probably, I don't know if this trick is taught in England, but if you consider the second derivative, which is 8, which is always greater than 0. So if the second derivative of a point is greater than 0, then that point is a minimum. And if the second derivative is of a point is less than 0, then that point is a maximum. And in this case, since it's always greater than 0, this implies that 3/4 is a minimum. So I don't know if that's cheating a little bit, but I'll go with it. Question 8. The function f is such that that is less than 1 for that trapezium. I can't remember what the trapezium rule is. I think it's something about partitioning your function into trapeziums rather than rectangles to estimate its integral. Okay. Produces an underestimate. So I guess if you have a function like that, your trapezium is always, I guess, underneath the graph, so that it is a little bit less than its actual integral. One. Okay, so A is definitely not the answer, because if you add 1 to it, then this, let's see if I can move over my pen, then this would just go up by 1, so that the trapeziums at the start still remains an underestimate. So let me put a cross beside that. b, so you're scaling it by 2. Scaling it by 2. That probably doesn't change the fact that it's an underestimate either. If you kind of just double it. Proving by picture here. I'm gonna say no to that as well. That doesn't look right. Shifting it to the left 1 unit, but integrating it from -1 to 0. That's definitely not it either. Okay, the last two are a bit tricky. You're reflecting it in the x-axis and integrating from 0 to -1. I guess that's the same. If you reflect it in the x-axis, that wouldn't change the fact that the trapeziums are still an underestimate. You're just reflecting it. But then you're integrating. I guess that follows from the same logic as part C, as option C. So it's probably not D either. Oh, this is a poorly done question. I'm guessing it's E, since I've eliminated all of the previous 4 options. 1 minus f of x. So you're reflecting it. So now we'll look like something like this. Then you're moving it up by 1 unit. So going up like that. Maybe. Yeah, I'm just going to go with E. Hopefully I'm right. That was a very badly done question. Okay, question 9. P is a positive constant. Oh, finally. This one I definitely can do. All right. So we rewrite this as y is equal to x squared on p squared. Then I guess the area enclosed will probably look something like this. And this is the area. So that means we need to find their intersection points first. So p root x is equal to x squared on p squared. How about we square both sides again, so that p squared x is x to the 4 on p to the 4, which then implies that x to the 4 is equal to p to the 6 times x, which implies x, take out x cubed minus p to the, should probably write out how I got there. So p to the x to the 4 minus p to the 6x equals 0. So that x cubed minus p to the 6 is 0. And then either x is 0 or x cubed equals p to the 6, or x is equal to p squared. So that means this is 0, and whatever this is p squared. Now you integrate from 0 to p squared of p root x minus x squared over p squared dx. So this is, I'll rewrite root x into x to the half, so that this is p to the p times x to the 3 on 2 divide by the new power, which means you're multiplying by 2/3 minus x cubed over 3p squared. I think I've done that right. So that this is, so when you substitute 0 in, everything just becomes 0, so we don't have to subtract anything. So we just substitute p squared in. That means 2p times p squared to the 3 on 2 on 3 minus p squared cubed over 3p squared, which is 2 times p. The 2 cancels out, leaving you p cubed. Multiplying that by p gives you p to the 4 over 3 minus p squared cubed is p to the 6. Canceling that out with the denominator is p to the 4, which is that. And this nicely cancels out again to give you that. And the answer should be D. Ooh. Halfway there. Question 10. Evaluate the absolute value of x times 1 minus x dx. So the absolute value of x is equal to x if x is, I guess, greater than or equal to 0, and minus x if x is less than 0. So that means you can split this integral, or just write directly below it, into -1, 0 of minus x, 1 minus x dx, plus 0 to 3 of x times 1 minus x dx. This is just using the piecewise function of the absolute value of x and then splitting the integral into its appropriate endpoints. Let's expand this to get minus x plus x squared dx plus x minus x squared dx. It's nice when you know what they integrate to. 3, 0. Plugging 0 for the first one, that's nothing. You just get zeros all the time. So let's just put -1 in. Remember to put a minus sign at the front because -1 is the second endpoint. So minus a half. -1 cubed is -1 again. So that's minus a third. Then plus 9 on 2 minus 27 on 3. I'll rewrite that as 9. So this is a half plus a third plus 9 on 2 minus 9. A half plus 9 on 2 is 10 over 2, which is 5. 5 minus 9 is -4, and then -4 plus a third. So this is what? -11 on 3, and the answer is F. Okay. Oh, there's 11 on 3 on there, but I think I did all the calculations right. The answer should be negative. What is this? Logs. Whoa. Find some. using the log identity for adding, this is equal to log 3 of x plus 2 log 3 of y. Just pull the index down and make it a constant. So that's true. Oh, I see. The second equation implies log 3 of y is minus 3 times log 3 of x. Then you substitute this into here so that we get log 3 of x minus 6 log 3 of x equals 1, multiplied by the lowest common denominator on the left-hand side, so that you get log 3 of x whole thing squared minus 6 on log 3 of x is equal to 1. Then multiply by log 3 on both sides to move this up here. I'll just do that in one line. I don't want to risk having no space left. Then this becomes a quadratic. I'll let what u log 3 of x star and star becomes u squared minus u minus 6 is 0. And like, yes, this factorizes nicely. U plus 2, u minus 3. Yep. So that u is equal to minus 2 or 3. But then this means log 3 of x is minus 2, or log 3 of x is equal to 3. Then this means x is, for the first equality, x can be, I think it's 1/9. And this one is 27. Therefore, sum is, I don't like leaving it in mixed fraction, but that's what option H is. Great. Question 12 is given that this derivative, nasty. Oh, here we go, question 12. Okay. Yep, it's a nasty looking derivative here. Find the value of t. Oh, find the value of v when t is equal to 9. Whew. Okay, that's, so I need to integrate this. Okay. Okay, I think I see how to go about it. Okay. Right at the top, notice that 1 plus the root t times 1 minus that is equal to t minus 1. Difference of squares. So 1 minus root t is equal to t minus 1 on 1 plus t. So then we can make that substitution into here so that this becomes 24 pi times 1 minus the square root. And now this can be integrated very easily. Integrate 24 pi minus 24 pi root t dt. What does this give you? 24 pi t minus 24 pi t to the 3 on 2 divide by 3 on 2, which is the same as multiplying by 2/3. 24 multiplied by 2/3 is 16. So then this just becomes 16 pi. And since this is an indefinite integral, let's not forget the plus c, where c is a real number. That's v. And then, oh, okay, so this information helps you find what c is. So therefore, so now 7 is equal to 24 minus 16 pi plus c. So that c is 7 minus 8 pi. Okay. And then now what? So v is 24 pi t minus 16 pi t to the 3 on 2 plus 7 minus 8 pi. Oh, I think I made a little algebra error here. This should be root t plus 1 and root t minus 1. Oh, gosh. So that this is root t minus 1. Root 24 pi root t minus 24 pi. Check a minus sign here. Here's a plus sign, minus sign, plus sign, so that this should be a plus. Yes, I think that's right now. Okay, and I guess let's substitute 9. Let's do it on the side here. 24 times 9 is 216, so that's 216 pi. Then 9 to the 3 on 2. So 9 is 3 squared. The 2's cancel out, so that's 3 cubed. So that's 27. Then 27 times 16 is 432. So minus 432 pi plus 7 plus 8 pi. Does that look right? Oh, whoops, this should be plus. Okay, so 432 plus 216 plus 8. No answer, has 5 in it. Hmm. Oh, the minus sign. Yuck. So 432 minus 216, then minus an 8. That's 208. Is that right? It looks right. Here's 208. Let me look through this. I've made a lot of mistakes in this question. So 24 times 9 is 36. That is 216. That's minus 216 pi. Oh, no. Why did I subtract 8 before? This is 224 pi plus 7. My goodness. Okay. Oh, this was a very tiring question. Whew. Okay, this should be right now. Find the maximum value. Damn. Okay. I think this is another one of those quadratic questions. So 4 is, so this is equal to 2 to the 2 sine x. So let y equal to 2 to the sine x, so that star becomes y squared minus 4y plus 17 on 4. And I guess it's equal to 0. Okay, then find the maximum value. Oh, okay, so it's not, I guess let's do f of y. Then f prime of y is 2y minus 4. If you set that equal to 0, that means y is equal to 2. But then that means 2 of sine x is equal to 2. But then that means, so now this is 2 to the 1, so that sine x is equal to 1. But there are no values here. sine x. Not sure about this one's. Last few questions have been really tough. I'm guessing there's no maximum value. Or maybe I'm not meant to differ. Okay, if I differentiate that, I'll be finding, yeah. Okay, let's try a different approach then. What if this 17 on 4 doesn't look nice? So I'm going to try and complete the square. So the closest thing is 4 and minus 4. And then just plus 17 on 4. So that this simplifies to y minus 2 squared minus a quarter. Or maybe I should say plus a quarter. So then this is the turning point. So turning point at 2 a quarter. Which is already given from here. And then if you differentiate this twice, you get 2, which is always greater than 0. So that means 2 is a minimum instead of a maximum. Not sure about this question. I'll put a question mark next to that. I'll come back to it later. Okay. Well, the second half of these questions are so hard. Question 14. Here's equation 1. Here's equation 2. X satisfies that. Okay, so first thing I'm seeing is I should do, what if I do equation 1 plus √3 times equation 2? So that I get sine of 2x plus √3 cos of 2x equals -1. This is plus 3 sine of 2x minus √3 cos 2x is equal to 3. Then this becomes 4 sine of 2x is 2. So that's sine of 2x is a half. And if sine of 2x is equal to a half, then cos of 2x is equal to minus √3 on 2. I think that's, yep. But then, oh, it's 1 degrees, not radians. What makes a half? So this means 2x is, I think it's pi on 6 is 30 degrees, but because of the domain, let's see, if you add 120, then you add 360 to that, to 30, then you add 360 to 150, 110. So that x is, the reason why we're going that far is because when we reduce down to x, we have all of these 4 values between the domain. As for sine, well, maybe I should just box it. And box this in blue. Now box this in red. Just enough space. What is this one? Minus √3 on 2. So that means it's in the second and third quadrant. So this would be 150. 150. So 210. Good, great. Then we just add 360 degree to all of them. So that x is 75, 105, 255, and 285. This is for cosine. So it says find the sum of the possible values of x. We have the values shared are 75 and 255, and they add up to 330 for an answer of B. Find non-zero solutions to the equation. This looks like another one of those quadratic questions, because I can rewrite 9 as 3 squared x so then this is 3 to the 2x, or maybe 3x to the 2. Then if you let y equal 3 to the x, here's star, star becomes 2y squared on 8y equals a quarter, which then implies and also 4 is 2 squared and 8 is 2 cubed. So 2 to the 3y. So that means 2y squared. You cross multiply both sides, you get times 2 squared equals 2 to the 3y, but then this means y squared minus 2 is equal to 3y. So then y squared minus 3y minus 2 is 0. This factorizes into these two linear terms. So that y is equal to 1, y is equal to 2. That means 3 to the x is equal to 1, 3 to the x is equal to 2. This means x is equal to 0 and x is equal to log base 3 of 2. But we know that the solutions have to be non-zero, so that this option is a no. And so the answer is log 3 of 2, and it's A. Given that this function, whoa, and that is 6, find the value of. Okay, so no assumption of what this function is. I'm just going to assume that it's smooth, continuous, whatnot. So notice that this is shifted to the left and integrate from 0 to 1. That means you might as well integrate from 1 to 2. So that means these two values are actually equal. So then that means this plus, so now this is 5 times 6 is 14. Therefore, is 14 minus 30 is minus 16 divided by 2 minus 8. But then this can be split into these two integrals. First one we know as minus 8, the next one we know as 6, for an answer of minus 2. I'm pretty sure it's, you don't know what kind of function this is. So I think that's it. Find the fraction of the interval. Oh gosh. You need them to be greater than or equal to 0. So I guess we'll use null factor law here. So we have sine 2 theta is equal to 1/2, or sine theta is equal to cos theta, which means if you divide both sides by cos theta, you get tan theta is equal to 1. Okay, so this one's in radians. All right, great. So 2 pi is equal to pi over 6 and 5 pi over 6. So that theta is pi over 12, 5 pi over 12. And this is only pi over 4. Yep. Then so from the behavior of this function, that means this is positive on the interval. So it says find the fraction of the interval. So I'm just going to write my answer in interval form and then figure out the answer from that. This is always positive on this interval and negative on, I guess, this interval here. Whereas this is positive on everything bigger than pi over 4. So pi, yep, and negative on 0, pi on 4. And so if the product of two things is greater than or equal to 0, that means they're either both positive or both negative. So that means we just let's see, how do I write this properly? Therefore, both positive on, and this is the intersection. Which is pi on 4 is 3 pi on 12. So this is pi on 4. And both negative on intersect this set here. Apologies for any messy notation. So then this is, if you intersect that, then you just get, oh, I think you just get this. Because this bit just kind of gets ignored. And if you intersect it with that, you just get 0 and pi on 12 back, because pi on 12 is smaller than pi on 4. So then therefore, so once the fraction of the interval, so I'm guessing you just take the difference. So so you just do pi over 12 minus 0 and 5 pi over 12 minus pi on 4, which is pi on 12 plus 2 pi on 12, which is pi on 4. And the fraction of that is a quarter. So C. That was a fun question. Got a little bit of set theory notation in there. I could also use measure theory notation. Put the M there. Yeah. But that's definitely outside the scope of high school. Find the shortest distance between, okay. You differentiate the curve to get 2x, as well as the line to get 2. For them to be both equal, x has to be 1, which means 1, 5 is the point on x squared plus 4 closest to 2x minus 2. So you, something like this. and then 2x minus 2. I'm guessing like this point here, 1, 5, is the closest to this line here. But look at the dotted line. That means you have to find the perpendicular. So, and we know that the perpendicular line has the negative inverse, has its gradient as the negative inverse of the line. So that means the gradient of this perpendicular line is -1/2, because we can use the point gradient formula to find the equation of that line, because it intersects, well, because 1, 5 is one of its points, so that y -5 is -1/2 of x minus 1. So that y is -1/2 x plus 1/2 plus 5, but then that's just 11 on 2. Now we find their intersection point, these two lines, that represented by the red dot that I just put on there, which means now we have 2x minus 2 is equal to -1/2 x plus 11 on 12, which means 5 on 2 x is equal to 15 on 2. So that means x is equal to 3, and so y is equal to 4. So now we have this point here, 3, 4. And so the distance, we use the distance formula. So distance is, so we calculate distance between 1, 5 and 3, 4. So 3 minus 1 squared plus 4 minus 5 squared, which is what? 4 plus 1. Root 5 is the answer. And so that is B. Sum, finally. Great. Find the value of, oh, there's going to be a lot of canceling out here. So if k is 0, oh, make a table. K and sine of 10 plus 90k. If k is 0, we have sine of 10. If k is 1, sine of 100, k is 2, sine of 190, but 100, you can write this as, but if you think about it, that means that it's in the third quadrant, so where sine is negative. So this is minus sine of 10. When this is 3, this is 280. But then the similar process applies again. This is minus sine of 100. And if this is 4, this is 370, which is sine of 360 plus 10, which gets you back to the first quadrant. So from this observation, every 4 terms cancel each other out. So we can just ignore everything, every 4 terms. That means 0, 1, 2, 3, they cancel each other out, and then 4, 5, 6, 7 cancel each other out. So if you just think about it in your head, you would have the 88th, the 89th, and the 90th term left. So this is just the sine of 10 plus 90 times 88 plus sine of 10 plus 90 times 89 plus sine of 10 plus 90 times 90. And then you know that, again, just by thinking about it, this should be equal to sine of 10. This is sine of 100. This should be minus sine of 10. Just kind of matching the, just kind of figuring out the pattern, I guess. So then this is just sine of 100, which is C. Okay, finishing off with cubic, I think, for the last question. What is the complete range of values of k for which the curve with equations x cubed minus 12x and k minus that intersect at 3 distinct points and 2 have positive, wow. Okay, so if you're talking about intersection, you intersect both lines. So you have this equality. Then if you move everything to both, I'm going to expand the binomial and then also move it to the other side. I'll just do it all in one go. So that just be what? It will be plus x squared minus 4x plus 4 minus k is 0. Yep. A little bit of simplification. 0. And what? Well, if they're intersecting at 3 distinct points, that means the graph, that means whatever graph this is should have 2 stationary points. So if you differentiate, if you make this f of x, then its derivative is 3x squared plus 2x minus 16. Then by the quadratic formula, minus 4 times 3 times minus 16 over 6. That is minus 2 plus or minus 4. 48 times 4 is 192. 4 plus 192, 196, square root of that is 16, which is 6. This gives you so minus 2 plus 16 is 14 over 6, which is 8 over 3. If you minus 16, you get minus 3. Wait. Minus 18, which is minus 3. Yep. Oh no, that's not right. Should be 14, shouldn't it? 196. Yep, 14. That's 2 or minus 8 on 3. All right, great. So then I guess f of 2 is equal to 8 plus 4 minus 32 plus 4 minus k, which is minus 16 minus k. And then f of, oh, this is horrible. minus 8 over 3 cubed plus minus 8 over 3 squared minus 16 0 over 3 plus 4 minus k. 8 cubed is 512, so minus 512 over 27 plus 64 on 9. 16 times 8 is 128 plus 4 minus k. I've almost used up the whole page. And then this is, you put them all over 27. 64 times 3 is 192. 128 times 9 is 1,152. 27 times 4 is 108. Then this whole thing, you add these up first and then subtract 512 for, should be 940. I'm gonna put that here, which is 940 on 27 minus k. Okay, so 2 turning points. I guess also notice that the y-intercept of this is 4 minus k. So since all of them have minus k's, you kind of get an idea of where they need to be. So, I mean, this fraction is massive. So it should be somewhere up here where this is minus 8 over 3. And 4k, I mean, if it's down here, so there are 2 cases where, okay, how about I make this smaller? And make case 1 and case 2. Case 1 is where it looks like this. Case 2, where it looks like this. But case 2 is not what we want because it has 2 negative x coordinate, but we want positive. So we can only look like this. Let me erase that. So here is here is minus 8 over 3. Yep. Here should be 2, and here is 4 minus k. And since 4 minus k is above the x-axis, that means 4 minus k is greater than 0, or that inequality. And then because minus 16 minus k is below the x-axis, that means this is less than 0, so minus 16 is less than k. So if you combine these two inequalities, you get that k is bounded between minus 16 and 4 for an answer of E. Come on, circle it. Great. Okay, and that's the end of the exam. I'm just gonna flip back and have a look at that weird question again. Where is it? Ah, here, the question mark. So I guess, so y equals 2 is a minimum. Okay, we know that sine is bounded between -1 and 1. So here's a graph of sine. So here's 1, here's -1. But if but if sine, the max of sine, so the max of sine is 1. But if the max of sine gives the minimum, then the minimum of sine gives the maximum, i.e. y equals 2 to the -1, which is a half. Is a half on there? No. Not sure now. Or maybe I just substitute back, I guess. So that means f of a half is I'll do it, a quarter squared minus 4 times a quarter plus 17 on 4. That is a quarter minus 2 plus 17 on 4. That's 18 on 4 minus 8 on 4, which is 10 over 4, which is 5 over 2. And that is one of the answers. I'm not sure about this question. This one, I guess I'll put it in red pen. Maybe, I don't know. There is no max. I'm not sure about this one. But I'm pretty sure all the other ones are right. And I'll have go and check out the answers to this exam later. But yeah, this has been a really fun exam to do. And I'm pretty sure I went over 75 minutes. So I really admire the students who can finish this exam and can get a high mark on this. And I guess this is my first time doing an exam like this. I hope to do many more if this video goes really well when I put it on YouTube. I'll stop the broadcast there, and I'll also end the video now. Thank you all for watching me do a math exam for 1.5 hours. Thank you.